I don't care how it looks. I'm saying it's a square. If it's a square, you have to think of two ideas for the definition, not just four equal sides. Four right angles. So two ideas give you the square. You can think of a square as a rectangular rhomboid or a rhomboidal rectangle. It's a rectangle and a rhombus at the same time. Also, it is a parallelogram. So it has everything from those last three sheets that we did. It's got all of those characteristics. It's got all the extra diagonal characteristics. If you want to look at the definition, you'd be looking at this. Four right angles, four equal sides. Put that into your drawing. We've only got one square because we would put everything into this. Put in two diagonals. Because it's a parallelogram, the diagonals cut each other in half. So put in those slash marks. That's because it's a parallelogram. They're all equal because it's a rectangle. And the rectangle had diagonals that were the same length. Because it's a rhombus, what can I put in the exact center? Put right angles in the exact center. Because it's a rhombus, the diagonals bisect the big angles. What's the big angle? So what does it get split into? 45, 45, 45, 45. In fact, all of these little angles are going to be 45. So now you might have to start thinking about Pythagorean theorem again. Special right triangles, the 45, 45 had a certain pattern. Those might come up in a square problem. But it's got everything. What? It's got everything. So all the extra characteristics that we already talked about for the rectangle and rhombus are here. Nothing new on top of that. It's just all in one nice, neat package. Put a line here. This now separates the parallelograms from everything else. Everything we've talked about so far was a parallelogram. The sides were parallel to each other. When we get to a kite, not true anymore. Let's write kite. Two pairs, congruent sides, but opposite sides not equal. This is written in a lot of different ways in a lot of different textbooks. Basically, this is the definition. And it is a mathematical term. Kite will show up in a lot of different textbooks. You just have to have consecutive sides being equal. These two, but not the ones that are directly across from each other. If the ones were directly across from each other were equal, then you'd end up with something like a parallelogram or a rhombus. This is sort of symmetric. Because depending on how you look at it, it could be symmetric from left to right or from the top to the bottom. Let's put 120 here and 120 here. The way these are set up, it's symmetric from left to right, but not necessarily from top to bottom. Let's put 70 degrees here. If this was 70 degrees, or if this was equal to this, then it might be a parallelogram, and that's not what we want. So 240, 310, this would be 50 degrees. So some of the angles are going to be the same. Some of the angles are going to be the same, some are not. What are they going to all add up to? 360. So look for symmetry, but not total symmetry. If you have diagonals, what does it look like you get right in the middle here? Perpendicular. So just like a rhombus, the diagonals are perpendicular. Let's use this information over here. What do you think happens to the 50? That gets split in half. The 70 gets split in half. But the 120s do not. From left to right, you just have to figure out what's going on with the triangles. If you got 90 and 25, what's left for that spot? 65 here, 65 here. If the whole thing's 120, that leaves me 55 for here and 55 for here. So you end up with a bunch of right triangles. Some of them are the same, some of them are different. That's why I say it's sort of symmetric. Depends on how you're looking at it, left, right, top to bottom. Once again, right triangles show up. You got to know everything you did in Chapter 7, Pythagorean theorem. If you're ever stuck on a quadrilateral problem, it's probably because you're ignoring some triangle rule that you forgot about from the previous chapter. Put those away. Keep those all together in your notes. The next time I see you, we're going to have trapezoids. That involves a little more work because you have regular trapezoids, isosceles trapezoids, trapezoids with diagonals. I need you to do me a favor today. Put everything away except something to write with and your calculator. This is a participation grade. And the better you do at it, the less homework you're eventually going to have. You're going to have 10 questions. These 10 questions were taken off of old SOL tests, and they have to do with everything from Chapter 1 through Chapter 7. I want to see what you remember. Do as much work as you can right on here. Put your name on here. This does not leave the room. When you're done, my student aide will put them in period 2 SOL bin.
Who's that?
Devon Fang, I think is in Fang. She puts all of these little reviews that we do into this box. And then the week before SOLs, I hand you the entire folder of all of our review books. So in addition to your notebook, you also have a folder that we've been keeping for you. I look at this, I see some parallel line problems. I see midpoint on here. I see converse on here. So I'm doing this to see what you remember and what you don't remember. If everybody does well, please listen. If everybody does well on the similarity problem, I know I don't have to review that before the end of the year. But if everybody has problems with the midpoint problem, then I know I need to review that. You're not getting graded on your grade. If I see that you're doing your work and you're taking this seriously and you're not looking in your notebook, you're going to get credit for this as a participation grade. But do your best at it. This helps me figure out what I need to review in April. Start your work on here. I'm going to pass out a little Scantron sheet that you can put these answers on. The questions go from 36 to 45. The Scantron says 1 through 10. Can you figure it out? Can you put the 10 questions on there, even though they don't match up? 10 questions to 10 questions. I don't think so. You want some there? No talking. No talking. Okay. After you're through with this, bring up both sheets to me, and then begin your workbook work, which is on the sideboard. Some of that you hopefully started. The rest of it is new. Put your name on here to begin with. Show all your work on here, circle all your answers, then transfer them onto here. I'm interested to know what you know. Just look at your own paper. These questions were taken directly off of old SOL tests or patterned after SOL style.